All right, in this video, we are going to finish up section 3.2, talking about properties of a function's graph. So in the last video for this section, we went over all the information that you would need to know, but that comes to a graph and the properties you have to find for it. What I'm going to do in this video is show you a long problem. So there's one problem on your homework and possibly your quiz where you will have to find multiple different things from the same graph. So what I decided to do is, it's going to take me 2 slides to do this, is I've got a really ugly graph here. And what I want to be able to do is find every single thing that we talked about in the previous part of this section's video. So as we go through this, we're going to go one by one and review every little topic I went over in the last video and then find it on this graph. And I've got A through E on this slide, and then we'll do the rest of them on the next slide. So beginning with domain, find the domain of this graph. So remember, the definition of domain is the x values of your graph. And so I told y'all the easiest way to do this is to first find the point on the graph that is furthest to the left and furthest to the right. So as far as the left goes, the furthest left that this graph goes is at -8, -3. And since we're doing x values, I will use -8. And the furthest to the right this graph goes is out here at the point 9,0. So we'll use the x value of 9. Now, since the first dot had an open circle, remember that means you're going to use a parentheses. And then since the second dot on the far right has a closed circle, we will use a bracket. And so that is the domain of this picture. Versus the range is the opposite. We now want to look at the y values. So for y, I want to find the lowest point and the highest point on this graph. The lowest point actually occurs right here, kind of in the middle at the bottom, at the point -2, -5. But since I only care about the y values here, I'm going to use the y value of -5. And then if I look for the highest point on the graph, it occurs at the point -6, +3. So kind of the top and to the left. Once again, from that point, the only number I care about is the y value, which is +3. Now, since both of those dots are closed in circles, we can just use brackets in order to express our interval. And that would be the range of this graph. For part C, we want to look at the idea of where is this graph increasing, decreasing, and constant. So we're going to go piece by piece for this. So remember, with these three, you're only looking at the x values. And remember, we don't use union symbols. We use commas. And also, we don't use brackets. We only use parentheses in increasing, decreasing, and constant. So beginning with increasing, finding all the spots where this graph is going in an upward direction. The first one would be here at the very beginning, where we start to increase at x equals -8, and then it stops increasing at x equals -6. Then I'm jumping all the way over here to this third section where we are increasing. So I'm going to put a comma. And in this third section that I have dashed off, we start increasing again at x equals -2, and then we stop increasing at this value of x equals 1. But there is a third section I have to do. My third section of increasing is way over here, where I will start to increase again at x equals 4. So I'll put another comma and then 4, and it stops increasing at x equals 7. And so in this graph, there are 3 different pieces where there are increasing parts. And so that's why I've got 3 different intervals that represent the increasing of this function. Now, as far as decreasing, I'll do this one in blue. You're looking for where is the graph going down. And so in this case, I only see one big section where it's decreasing, and that is this part on the left-hand side. So since that's the only piece where it's first going down, I'm going to write that one first. That would start at x equals -6, which is right there, and it ends here at x equals -2. Now, I misspoke. I overlooked the other one by accident. On the far right, there's also a second section of decreasing way here at the end. So I also want to include that one. So comma, This one begins decreasing at x equals 7, and then it finishes decreasing at x equals 9. So this graph has two sections of decreasing, so make sure you get both of those intervals and we have a comma between them. Finally, and I'm going to go back to purple here, we want to find our constant interval. So that's the section of the graph that's not going up or going down, it's just flat. And that occurs right here in the middle. And so this one has a constant value that starts at 1 and it ends at 4. So your only interval of constant is between 1 and 4. Just once again, remember, with increasing, decreasing, and constant, you only look at the x values, you only use parentheses, and you use a comma between them, as you write more than one. All right, so for part D, I need you to find all the relative minima of the location. So from the last video, the definition of a relative min is any time that you go from decreasing to increasing, that would be a relative minimum. So let's figure out how many spots have a relative minimum. And I'm going to use a little green star for this. I see one, actually I only see one. There's this one spot right here. At the point -2, -5, that is the only spot on this graph that you go from decreasing to increasing. So that would be your relative minima. So the relative minima would be the y value of -5, and then the location would be the x value that it happens at, which has an x value of -2. This is your only relative minimum on this picture. All right. Now moving to relative maxima, which is part E, and then we'll go to the next slide. Relative maximums occur whenever your graph changes from increasing to decreasing. So we've got to find all the spots that go from increasing to decreasing on this picture. And so as I look through this picture, I actually see two spots. One of them is here, and the other one is over here on the right. Those are the only two spots where your graph changes from increasing to decreasing, and thus we can actually write our maximum. So the first one, so we'll start from left to right. The first one has a relative maximum of 3 because that's the y value, and this is occurring at x equals -6. So that would be your first relative maximum. The second one, if I go over to the right, has a y value of 2, but this one occurs at x equals 7. And so it's perfectly fine for a graph to have more than one relative maximum as long as you can identify that it matches the rule of increasing to decreasing. And same thing, you might get one on your homework that has more than one relative min. That is okay as long as it follows the definition of decreasing to increasing. Now that's the first 5 things, but I didn't want to jumble too much on one slide. So on the next slide, what I'm going to do is I'm going to give us a clean picture. And I've got 5 more things I want us to be able to find, and that'll wrap up this video, because since this problem is so long, it's a video in itself. So on part F, it says find the real zeros. Remember from the last video, when I say real zeros, I'm talking about the x-intercepts. So you want to find every point on this graph that it crosses the x-axis. So that would be 1, 2, 3, and 4. There are 4 different dots that I see on the x-axis, so I'm going to list all of those under part F. That would be at -15/20, comma, -40, comma, 50, comma, and 90. So this graph has 4 real zeros, aka it has 4 x-intercepts. All right, now you want to find the y-intercept. So the y-intercept is find the spot where it crosses the y-axis, and there's only one spot that happens in, and that's going to be at the point 0, -3. And so that will be your only y-intercept for this problem, and that's the answer to part G. On part H, it says what values of x is f of x less than or equal to 0? Now remember from our discussions here, f of x is the same thing as y. So when it's asking you where is your y values less than 0, that means you are looking below the x-axis. So anytime that your y value is below the x-axis, we call that a negative number. So what I need to do is I need to shade in what parts of this graph fall under the x-axis. So I'm going to use a little dotted line here. Boom, 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 boom. So I'm going to do all of it. We'll shade it all in. I think that's it. All right. So in this case, oh, sorry, I missed this part over here. My apologies. And then we'll come back to this star here, this part at the end in a minute. So if I go from left to right, I want to write out the intervals of where f of x is less than or equal to 0. Now, it's telling you in the problem you have to use your x value. So that helps us out a little bit. So on the first dotted region, I'm going to start at x equals -8, which gets a parentheses. And then you're going to go up to this first dot, which has an x value of -15/2. That one gets a bracket. And once again, we're not doing increasing and decreasing, so I can go back to my parentheses and bracket notation. All right. Your second one is pretty long because it starts to go below the axis at x equals -4, so right here, and it stays below the x-axis all the way until you get to x is 5. Now, both of those are going to get brackets because they have closed circles there. I'll put my comma between them. And then over here at the very end, the reason I'm putting an arrow at 9, 0 is because since there is an equal sign on my inequality, not only must I write down where it's below the axis, I have to also include where it touches the axis. So even though it doesn't go back below the axis here at the end, it does get back to it and stops, but that's just at a single number of 9. So we don't do this very often, but anytime just one number is needed in an interval, we will put braces around it. And like I said, we're not going to see that very often, so don't panic about it. But anytime that you want to include only a singular number in your interval, you will use the brace notation because you can't use interval because there's not more than one number. So a little trickier there, but that's all the spots where the graph is below the x-axis. On part I, how many values of x make f of x equal -3? Once again, remembering f of x is the same thing as y. So you're asking yourself, how many different times is there a y value of -3 on this graph? Well, if I go to y equals -3, which is right here, just ask yourself, look left and right, how many times does it cross? Well, there's one here. Even though it's not labeled, there's one right here, and I'll put a little dot there just so you can see it. And then over here, you're not going to include this one because it is an open circle. Because remember, we cannot include open circles in our answers. So if you go back and double check, if you look at this entire graph, when it asks you how many x values cross at -3, there are only 2 times this graph equals -3 because we cannot count the third one because of the open circle. And finally, what is the value of f of 2? So remember, when we were plugging numbers in the last section, the numbers that you were plugging in represented the x values. So if I'm giving you an x value in the problem, which is x equals 2, you're being asked, what's the y value? So you want to go to your graph and figure out what is the y value at x equals 2. So 1, 2. Here is x equals 2. And if I go straight down, my graph is, or my dot would be right here on the graph below it. Now, even though this point is not labeled, you'll notice that this is the section of the graph that we called constant on the previous slide. That means since that section is constant, every value is the same because it's a horizontal line. So at the left side, since it has a y value of -1, and on the right side, it has a value of -1, that means every y value on that section of the graph has to be the same thing. So therefore, our y value must also be -1 there. And so when you get to your homework, please do not panic. You're going to see a problem very similar to this where you have to find 8 to 10 things. Just take your time through it and find each piece appropriately. And so that ends the second video for section 3.2. So we talked about the properties graphs in this case. So in the next in the next video, we are going to move into section 3.3, where we are going to talk a little bit more about graphs of basic functions and graphs of piecewise functions over a 2-video sequence.